My dear students, so today lecture we will discuss about the modern database models. Like, so before going to the actual content of the content, so we will discuss the outline of the today presentation. So that is like relational database model, NoSQL overview, and we discuss the types of NoSQL also, like key value and document model, column family, graph model. So basically we are going to discuss two databases, right? So one is a relational database model, one is a NoSQL database model. So these two we will discuss in a today class. Right, first we will discuss relational database model. Right, so relational database model is invented F code in 1970. So what is that is that relations should have some association, right? So it means that it is every relational data model is organized like in a form of table with clear structure, right? So as per our standard definition, what is a database? Database is a organized structured data, right? So data is organized in the form of table like rows and columns, right? So it means that it is as per standard form, it is organized and structured, right? So that's why we can say it is a as per standard definition it is following, right? So now we will see the one example with a student table, right? So we will call it as a like relation also we call it. We don't call in a table as technical terminology, we will call the relation is a table, right? So in this one there is a two types. So if you row we call it as a tuple, where column we call it as a attribute. So in a simple terminology we call it as a rows and column, whereas in technical terminology we call it as a tuples and attributes. Simple, very simple. Tuple means it is a row, attribute means it is indicate the column, right? So now you can see why we call it as it is a relational data model. So you can see 101 and 102, 103 and 104, right? So these are the all are numerical numbers, right? So it is all are numerical numbers. So it is having some similarity, right? So these are grouping together, so in a form of relation. Same way here name, age, department, right? So that means that every row or column we can say a tuple and attribute, it is a have some of the relationship is exist. So that's the reason we call it as a relational database model, right? So you can take example, it is a student database. So here student ID, name, age and department, right? So there is a, for example, you take the here student and here it is a department. So I want to connect these student and table, right? So how the relation we are connecting with one by one with the help of key concepts, So what is a key? Which is uniquely identify the record in a database. That is a key. So that may be primary key, foreign key, etc. There are many number of keys like primary key, right, foreign key, candidate key, composite key, etc. is there. So at the time of discussion with the data normalization, we will discuss in more detail, right. So some of the terminologies we will discuss first, then we go for the that keys concept so that we will understand better. So relation is a table, right. Tuple we call it as a row, attribute we call it as a column, right. So again domain is a some set of valid values for attribute. So for example, if you take the student roll number, roll number, it normally it is having integer value. If I am trying to enter some character like A, C, something like that, so in that case it is a not a valid roll number, right. So that means that some set of valid values for attribute. So this is the domain. Next one, primary key, uniquely identify the each record. So what is a record? This is a one record, one row. This is a one record, this is a one record. So if I pick any of the attribute from the table, what is the attribute? So this is a attribute, this is a one attribute, this is a one attribute, this is a one attribute. If I pick any of the attribute, if it is find the uniquely in each record, so then we can say those attribute is a primary key, right. So now simple you can take simple. If I take the Bob is a candidate name. In a student table, the Bob may be present in a BTech first year, BTech second year, BTech third year and fourth year. Maybe different sections also Bob may be present. So that means that with the help of name of the student, I am not able to find the unique record. So uniquely I am not able to identify the each record in the relation, right. So that means that I will not opt the name as a primary key. I will opt instead of name with a student ID. Student ID is having unique ID like 101, 102, 103, etc. So if I know the student ID, as we discussed, like is a primary key, so uniquely I can identify the any of the record in a table. So this is the necessity of or importance of primary key. Next, foreign key. So what is the foreign key role? Foreign key will link the relationship between the one table to the another table, right. So now I will explain one more example so that you will get clear idea. So now you can see there is a student table, right. So student ID I am taking primary key, let us say student ID I am taking as a primary key, right. So one more table is there, that is a course table, right. In course table there will be course ID, course name and student ID, right. So now what I will do, I will try to link with the student table and course table, right. I am trying to find the student relationship between the student table and course table, right. So in a general sense, if I combine the both table, so what we will find? We will find the sum of the similarity or some of the properties will be same. Similar properties you will find. So what is the similar properties in both the table? So student ID is a one attribute. Here one of the student ID it will be remain same, right. So as we discussed, here student ID we take a primary key because of it is the student ID attribute uniquely identify the each record from the table, right? So here student ID is a primary key, as we discussed earlier. It is uniquely identified, right? In this table, if you are taking alone in this table, so what is the student ID is there? That student ID is connected in the table from student table to the course table, which is a primary key of student table, right? So that means that whereas a student table, student ID act as a primary key, whereas a course table, student ID act as a foreign key, right? So that means that student ID is a same time it is a primary key and foreign key, right? Only one attribute, it is acting two different places, two different keys. I hope students are clear difference between the primary key and a foreign key. You remember like what is the primary key? Simple, which is uniquely identify the each record in a table, right? You pick any of the attribute from the table, but it should uniquely identify the record in a table. So that only we can take it as a primary key. Otherwise, we cannot take it as a primary key, right? So you may get one doubt, right? Sir, here you are taking 101, 102 as a primary key. You have said as per definition it is unique. But Rahul, Priya and Kiran also having unique name. So I can find. But you are correct. The problem is that maybe if I enter some other records, so Rahul may be present again. Priya may be present. Karan may be present. In general sense, student hall ticket number will be never be same if you take any of the student from the college, right? So naturally at 22 start, some student will start 23, some student will start 24, based on the branch and their classes it will be vary. There is no common, not common, there is no same roll number for two students even though they belongs to the same branch, right? I hope students are clear with the primary key, right? So next, foreign key. What is a foreign key? Foreign key is a key which will establish the relationship between the two tables. So then we get that key we call it as a foreign key. So in this two table, what is a foreign key? Student ID. Student ID is a foreign key for this course table. I hope students are clear with the what is the primary key and foreign key, right? So next we will discuss the relational data model, right? What are the features of relational database model? First one, it is a table based structure, as we are aware. It is a data independence. What does that mean? For example, if you have any table like some rows and some columns, if I add any column here or if I add any row in a bottom or up or middle anywhere, so it will not affect any of the data which are already present. So that property we can say it is a data dependence, right? So next feature is a reduced data redundancy. It means that when you are declaring that your student roll number is a primary key, so by knowingly unknowingly student roll number you are entering with same rule number again. Let us say student having 101 rule number. You are again by mistakenly you are entering 101 rule number. So in that case the rule number will be same as we discussed. It is a primary key, right? So it will uniquely identify the each record in the table. So it is violating the property. So in that case those type of records the system will not allow to enter the data into the database. So that what will happen, it automatically data redundancy it will get reduced, right? So next one, it will support the SQL. So that means that structured query language it will support, right? So it will support the structured query language. Next, strong integrity constraint. So simple constraint means it is a condition, right? So strong integrity constraint means it will having some properties related to the database. You will study more details about strong integrity constraint with respect to the transaction management, right? Next one is a easy data retrieval. If you are having relation in a form of rows and column with some primary key, you can fetch the any of the record information from the relational data model. In a relational. So that's the reason we say it is a easy data retrieval, right? So next one, how it is organized. So as we are aware, it is organized in a form of tuples and attributes. I am hoping that this is not need to explain in a more details. So what is the advantage? Advantage is simple and easy to understand because of it is having row and columns. Everyone can able to understand easily. Next one, high data consistency. So that means that whatever the data you are entering, that all data is accurate and reliable information. So it is a data will be more consistent. Better security. So it will the database model will provide better security as compared to the other model. So this is one of the advantage. Efficient queries. So you can write queries in efficient manner. Why? Because data is organized in rows and columns. You can write or you can fetch the any of the information from the relation or table. So that is a efficient queries. Next one is a supports normalization. So normalization is comes in the picture when you take the data anomaly. Right. So what is a data anomaly? There will be different data anomalies, that is a multi-value dependence, partial value dependence. So more details we will discuss at the data normalization concepts. So what is a drawback? Drawback is it is a less suitable for unstructured data. If data is unstructured, it is most probably it will not support. One more drawback is if it is large data set is there. If I want to combine both the data set in the sense table. If I want to combine, it is a very complicated problem because I need to check what is the common properties in both. Then if conditions satisfied, then I have to add it. So horizontal slicing is difficult. So what is the horizontal slicing? If you take any supermarket, right? So people are waiting for billing, right? So it is not able to cater the all people those who are in long queue. So in that case, they will establish one more billing counter. If not sufficient, they will establish one more bill counter. If it is not sufficient, they will establish one more billing counter. This is called horizontal scaling, right? Next, what is the example for these popular databases? MySQL, Oracle database, Postgres, Microsoft SQL Server, SQLite. These are the example for relational databases. Next one, NoSQL. Right. So in a NoSQL stands for not only SQL. Right. So NoSQL stands for not only SQL. So what we'll do? Previously it is supports the relational database supports the only structured data, whereas the NoSQL support the unstructured data, semi-structured data, very large data sets. Right. So unstructured means you can see here, this is the one data point, this is the one data point, this is the data point, this is the one data point, let us say. Three data points are not same. These are the different data points. Like for example, one is an integer, one is a float, right? One is a string, etc. These are the different data points. So those kind of application still it will support. It is not necessary that it should be in a form of table only. Next one, semi-structured data. So that means that it is not completely table, it is not unstructured data. It is combination of both the things. So same time, very large data sets. So if it is a table having very big table also, it can able to handle. High speed application. If you require high speed application, you can use it. Right. So next one, why NoSQL? What is the advantage of NoSQL using? Because of it is able to handle the massive volumes of data. If data is like scaling in enormous data you have, the relational databases is not able to handle those situations also. Still NoSQL database is efficiently able to handle. This is one of the advantage. Flexible data structure. So that means that whereas a relational database, it is having only rows and columns. It will not support the, if I want some other data set. So in this case what will happen? Definitely it is support the flexible data structure. That means that it is not compulsion that rows or column. You may use your own data structure so that it will be get more benefit. High scalability requirements. So if that relational database is not support the scalability in larger extent. So these are the some of the challenges we found in a relational database. Those challenges will be efficiently handled by the NoSQL. So that's the reason NoSQL is a we are using, right? So relational database, if you take the comparison with the relational database and NoSQL, so it is a fixed schema, NoSQL is a flexible schema. Fixed schema means it is having rows and columns, whereas a NoSQL it having rows and column and structure and semi-structure, everything. So this is the one of the advantage. Here it is a table based model, here it is a data model, like in a document value, key value, column value, graph value. We will discuss that in today class only. What is that one? So next one is a vertical scaling is possible in a relational database, whereas a horizontal scaling in a NoSQL, right? So best for structured data and ACID properties. So that is an atomicity, consistency, isolation, durability. We will discuss more details about in a transaction management. So whereas a NoSQL is best to suit for semi-structured and unstructured or structured data. So these are the comparison between the relational and NoSQL databases. Right. Next one. So what are the characteristics of NoSQL databases? It is a schema-less design. That means that there is no compulsion that database should be follow this structure only. Either you can follow the structure or semi-structure, unstructured, anything. So that is a schema-less. So next one is a horizontal scalability. I already discussed what is horizontal scalability, right? So high availability. Data will get high availability because it means that data will be stored in a form of structure, unstructured and semi-structure. So not necessary that it should be having some structure. So that means the data availability is increased as compared to the relational database. So this is the one of the characteristics. It is a fast performance in a distributed architecture. Why it is fast performance? Because of horizontal scaling is able to do. So that's the one of the advantage. So what is a distributed architecture? What is a distributed architecture? For example, what is a distributed architecture? If you take the client server system, there is a server and there will be different clients, let us say. So what is a server? Server means central system which will cater the all client requests. What is the client? Client means it is seeking some service from the server. This is the difference between the client and server, right? So now where we are distributed architecture. For example, this kind of architecture is there, right? Due to some problem, this server is failed. Due to some hardware problem, let us say server is failed, or due to some malware, the data get corrupted or data may be erased. So in that case, the server is in a trouble because of entire functionality of the system is stop functioning. So to avoid those kind of problem, the scientists started investing about to solve that problem. They started multiple servers in a geographical database having different servers like this interconnection. So if something is happened for this server, due to this one it is fail. So data will be distributed in all servers same, like what is the data is available in this one, this place it will be remain same, multiple copies will be shared. So due to some hardware problem, some power issue, this is went to the shutdown. So in that case what will happen? Still the remaining servers is able to function properly, the data will be available. So there is no problem of data erasing or data threat. It will be safe. Data will be safe and still able to do the functionalities. So these are the one of the characteristics of the NoSQL. So due to this one, what will happen? This fault is happen. That means that this server is not able to do the operation, right? So still that system is able to do function. So it leads to the advantage of fault tolerant. So that means that if some system face any problem, that system, if the situation is able to handle, then those kind of system we call it as a fault tolerant systems, right? So high performance because of these different, instead of one server, we are replace the one server with the 4 servers. It automatically capacity is increased, so it can perform better as compared to the single server. Handling big data, designed for very large volumes and structured, semi-structured data. So we already know. Flexible schema, we already discussed. It's not necessary that you should follow this kind of schema, that kind of schema. Similarly, easy scaling. You can increase as per your requirement. So what is the drawbacks? So one drawback is a limited support for complex chain. If you take the complex chain, it will not support always. Sometime it will not support. So that is one of the drawback in a NoSQL. What is a chain actually? Chain means simply combining of two relations or two tables. So that is a chain. So next one is a data consistency. Data will be maybe same, may not be. It is not compulsion that it should have data consistency is maintained. There is some problem. Few standard query languages. So data will be available in structured format or unstructured format or semi-structured format. We don't know because the data may be stored in a different format. So that means that we cannot write any programming for effective retrieval of information. As like as SQL is a standard query language, you can write queries in a standard form. Whereas a NoSQL, we cannot write like that. So it will be different problem. So there is no standard language for retrieving information. Next one is a complex transaction as compared to the RDBMS. So it is a very complex transaction as compared to the RDBMS due to the acid properties or something. Right. So popular SQL databases are documents by document store, key value, column value, graph databases. So time series also there, but I don't know whether we will discuss due to time constraint or not, but as of my knowledge, we will discuss these four. Okay. So next we will discuss one by. So these are the four types of NoSQL database. One is a key value, one is a document value, one is a column value, one is a graph databases. We will discuss one by one. So first one is a key value. So what is meant by key value? It is name is suggesting there will be some key followed by the value. Right? There will be some key, some value associated with key. As like a primary key, using that key, you can identify a unique record in a table. So that is about key value. So what is the key features? So there is a key feature. It is very simple because of one key having one value. So fast read write. If you want to write, if you find the key, you can write easily. Easy scalability, as much you can extend. There is no problem. Same like schemaless, high availability. So these are some of the key features about the key value. So you can see there is a one key associated with value. If I want to use this key, is automatically I can able to extract the value. So these are about the key value model. So what are the characteristics? Extremely fast lookup. If you want to search, we can search in a very fast manner. Because if you find the key value, you can get the value. It is a very easy. So simple structure, as we have simple structure. Why? Because of key and value, there is no problem for understanding this one. Easy scaling, right? It is a very easy scaling. You can do easily. High performance because of only key and value. So you can give the high performance. So what are the application? User session, shopping carts, gaming application, etc. This key value application. So what are the examples of Redis, React, Amazon DynamoDB? These are the example of key value. What is the advantages? It is a very fast retrieval because of it is having only key and value. It is a very fast. High scalability. If you want to scale, you can easily and simply we can implement this is easy manner because of it is having fewer constraints for retrieving or modification of database. So limitation, it is a limited querying. It will not support the complicated query. That means that if you want to fetch some other information, data itself is a very limited key and value. So you cannot apply the queries as much you can, but limited query it will support in a very efficient manner. So difficult for complex application. So it is one of the biggest problem. Role relationship exists between the records. There is no compulsory relationship exists between one record to the another record. This is one of the drawback. So next one is a document model, right? So what is a document model? So what is a document model? So there will be a document model like there is a three format, that is JSON and BSON and XML. JSON for JavaScript object notation, BSON for binary script object notation, XML stands for extensible markup language. So what is the example? Examples are MongoDB, couch GB and some of the file store. So these are the example for document database model. So applications, e-commerce, mobile application, etc. I am not discussing application in much more detail because of you are already aware how it is applicable in real-time application. Flexible schema because of due to the nature of the document model. So nested document, easy modification, store the complex data. So these are the some characteristics of the document model. Flexible schema, why it is flexible schema? You can see this is the one example. Student name, student ID, student name, department, subjects are there. It not necessary you should write the student ID, name and department as per your own discretion. You may write name first, student ID next, department later, subject third, something like that. So that's why it is a one of the flexible schema, and it is not compulsion that you should write only 4 values. You may write any number of values as per your requirement. So that is a flexible schema. Nested document. So if you take this is like one kind of document, you can use the sum of the below of the document. Easy modification. If I want to do modification, there is no relationship between this one and previous below document what has existed. So easily I can change the values in this field. So it is a easy modification. It will store the complex data. For example, here is a student ID is a integer, name is a Rahul, it is a character. If I want to store like sum 2x, bc, 4, 5, some kind of data. Just example I am giving. So those kind of complex data also I can store. So this is the one of the characteristics. Advantages: flexible data model, easy scaling, fast development, good performance. I don't want to discuss these things, how it is, those things. Right, limitation, there is a chance of data duplication. That means that what is the data is already existed, again there is a again chance. Right, complex changes are very difficult, consistency depends on the implementation. Right, so data consistency, how your system is implemented based on the consistency will continue. If implementation is good, then data will maintain high consistent. Implementation is poor leads to the inconsistent data. So these are the about document model. So next one, column family. So is column family as like as a same like key value, but only difference is this will give the more importance to the attribute like this. So whereas a key and value, right? Key and value. In this one, it is a column family. It is indicating that it will give the more importance to the column as compared to the row, right? So why it is giving? Why it is giving? Because of you take this age. Let us say this is the marks you take. I want to know the student average marks for particular subject. So in that cases, these fields are as per my requirement. These fields are not required. So this field is more than enough for me, so that I can directly fetch the marks field from the relation. I can find the average marks from the class. Okay. So these are the difference between the key value and column family model. Don't get confused, right? So these are some of the features are already there. We already covered these things. So I don't want to discuss again, right? So same features. Some of the features are common. So I compression, I discuss what is a compression. So remaining efficient storing, fast read, write, distributed architecture we already covered, right? So one is here high data compression, high compression. For example, you take you want to write one person name like ABC, right? So if I convert this ABC into form of like binary form. Let us say it is a 0 1 0 1 0 0 1 1. Let us say. So if instead of let us say for storing this one bit is required, 1 bit. Let us say how many bits? 1 2 3 4 5 6 7 8 9. 9 bits is required for store. So what I will do, instead of taking 9 bits, I will convert to the 0 0 1, right? Again 0, again 1. How many zeros are there? 1 2 3. I will write 0 suffix 3 1 suffix 2. So that what will happen? Automatically 1 2 3 4 5 6 bits it is able to store. So that means that from 9 bits to the, it is reduced to the 6 bits. So that means that 3 bits are saved. So this is the data compression. So that means that the data will be compressed into the small form, so that it automatically save the some of the memory and is efficiently use the network bandwidth also. What is the bandwidth? So capacity of network to transfer the data from one source to the another source, that is a bandwidth, right? So next one, graph model. So here it is a graph model is stored in a form of vertices and edges. So graph we call it as a node and edges. Graph is comprised of vertices and edges. So node also we call it as a vertices, also called as a entities. Edges represent relationships. Properties represent the attributes. So now you can see Bob friend Alice is a friend of Bob. So Bob and Alice is a entities or nodes. Friend is a edge. It is existing relationship. Similarly, Alice likes DBMS. DBMS Alice is a nodes, like is a relationship. So that means that like it is representing Alice is a one node, Bob is a one node, DBMS is a one node. It is having relationship like this. So this is we call it as a graph. Graph is a collection of vertices and edges. So this is a one edge, this is a one edge, this one, this point is a vertices we call. Right. So example Neo4j, Tiger graph, these are the examples of graph model. Right. So where will you use? Social networks, recommendation system, fraud detection, knowledge graph, all those things. So you may connect to the social networks like Instagram. So Instagram, for example, let us say 100 followers are there. For these 100 followers, there may everyone having the different number followers. Like let us say this is a one student, he having 100 followers. Like, and again this student also having some followers. Similarly, this student having some follower. So this is a one vertice, this is the one vertices, this is the one vertices, this is one vertices, this is a one edge, right? So in that way, this graph model will use in a social networks, recommendation system, etc. you can use. So features I don't want to discuss. Flexible schema we already covered. Fast graph travels. If you want to travel from source to the some other place, so you can travel in a very fast manner. So these are the one of the advantage. So comparison, because of you already aware, so I don't want to discuss much more about this one, right? So you may easily understand the comparison of different databases. Data model, relational model, how it is structured in a form of table, best for structured data. Example, MySQL, etc. Key value, it is stored in a key value pair. So it is used for catching session, etc. Graph is stored in a form of nodes and edges. So social network, Neos is a, Amazon Epcher is a, Mapune is a examples. So coming to the summary, we discussed the two concepts from today class. So one is a relational database, one is a NoSQL. So in a NoSQL there will be three categories. One is a key value, one is a column family, one more is graph database. So these are the three kinds we discuss in a today class. So, okay. So now thank you for watching. If you like my content, please hit the like symbol and share to the your friends and needy people. If you have any queries, please comment onto the comment section. I will feel happy to answer you. Thank you for watching. We will meet in a next lecture.